All right, let's get you ready for tomorrow's test here. Going over the practice test. Start with number one. Number one says if cosecant 7/4 find sine, you should know by now they are reciprocals of each other. So whatever they give you for cosecant, sine is a reciprocal. Don't miss that one tomorrow. Number two says find the value of cotangent and secant if you know what sine is. So what I did on that one is I did sine squared plus cosine squared is 1. You have to use what they give you. They gave me sine, had to use it. 1/36 came because it's sine squared plus the cosine squared is 1. I moved the 1/36 over. That gave me 35/36. I took the square root. I forgot to put the plus or minus there, but the reason I really didn't is because right over here at the end of the problem it says cosine is greater than 0, which means it's positive. So it had to be positive square root of 35/6. That's good, but that's not the answer. I need secant. So I took the cosine and flipped it, did reciprocal, and got that answer right there. And don't forget cotangent. Cotangent is cosine over sine. So I took my cosine answer, which was square root of 35/6. My sine, which was in the problem, 1/6. The 6's cancel, so it left me with just square root of 35. On number three, don't forget number 3 here that we did the other day gives you tangent, what the value is, and gives you cotangent x minus pi over 2. You really need it to be pi over 2 minus x. So what I did is I factored a negative out. Now, because it's not cosine, I have to put the negative in the front. That's what I did next, put the negative in the front right there. And once you put the negative in the front, cotangent of pi over 2 minus x is tangent. So it's really negative tangent, or the opposite of tangent. And since tangent was 1.128, the opposite of that is negative 1.128. Number 4, this just says simplify. And again, if you're looking at that, don't know what to do, change everything to sines and cosines, which is what I did. 1 over sine, 1 over cosine, cosine over sine. To subtract those, I have to find an LCD, which is sine cosine. This right here already has it, so I've just brought the 1 over. The sine, to become sine cosine, needs a cosine. So multiply cosine times cosine, that gives you cosine squared. And by now, hopefully, when you see 1 minus cosine squared, it's really just sine squared over that denominator. You can cancel the sines. That will leave 1 sine on the top, just a cosine on the bottom, and sine over cosine is tangent. Let's go to number 5 right here. Number 5 says simplify. Now, there's one extra mark on your test. For some reason, I accidentally typed an equal sign. Just get rid of that equal sign. I just marked it out right there. It should be a minus sign. Now, the good thing about this thing right here, this second part, it does say pi over 2 minus x, which means it's in the right order. And sine pi over 2 minus x is the same thing as cosine. So I just replaced it with cosine, and that gave me this. So what I did next, because they both have cosines, is I factored out the cosine. And that left sine squared minus 1. Now, 1 minus sine squared is cosine squared. So because they wrote it backwards, it's really the opposite, or they wrote the opposite of that there. So it's the opposite of cosine squared, which is negative cosine squared. Multiply those together and get negative cosine cubed. Number 6, another simplify problem. I went ahead first step here and just tried to combine the fractions. So multiply the denominators, got 1 minus secant squared. Cross multiply the numerators, cosecant times cosecant secant, and then cosecant plus cosecant secant. And the cool thing when you do that is, hopefully, the cosecant secants, those cancel out. So all that leaves you with in my numerator is 2 cosecants on the bottom. Tangent squared plus 1 is secant squared. So if you switch places with the secant and the tangent squared, you find out that that's really negative tangent squared. Now I'm going to change them to sines and cosines. 2 cosecant is 1 over sine. And what I did here, because it's divided by this, when you divide, you really multiply by reciprocal. So I wrote the reciprocal of tangent right there. Should have written tangent squared. I messed that one up. Let me fix it while I'm talking. It should be tangent squared. So it should be a cosine squared and a sine squared. Let's just finish it here, which would give me 2 over cosine squared sine cubed. That's a cube. I'm trying to write while I talk here. So I'm going to break that up like this. I'm going to say, okay, 2 cosine squared sine squared over, that leaves 1 more sine x on the bottom. So cosine squared over sine squared is cotangent squared, and 1 over sine is cosecant x. And that should be it, except for I forgot the negative sign. The negative sign is right there, so I'm just going to put that negative in the front. Sorry about that. I'm glad I caught it though while I was talking. That's one good thing about talking through these things. I can kind of catch some mistakes. Let's see, let's go to 7. 7 says verify. So this is what we spent one whole day doing. It was a great day if I remember right. I'm going to make the right-hand side look like the left-hand side. So I changed everything to sines and cosines. And what happened then is those two sines canceled, which gave me 1 over cosine squared minus 1. 1 over cosine squared is really secant squared, and secant squared minus 1, that's tangent squared. That's all you got to do on that one. Number 8, got two fractions added together. Do these the same way every time. Multiply your denominators. That gave me this on the bottom, cosecant squared minus cotangent squared. On the top, I'm cross multiplying. Really, because they're ones, I'm just putting this over here and this over here. And what happens is your cotangents cancel, which gives you 2 cosecant over 1, which is 2 cosecant. That wasn't that bad. Number 9, another one, doing the identity. So what I did on 9 is, it's hard to make the right-hand side become the left-hand side because it's hard to make that become a fraction with 2 terms in the bottom. So I took the left-hand side and I did this. I multiplied by the conjugate. That's a good strategy when you have a fraction, by the way, is multiply the top and bottom by the conjugate of the denominator. So that gave me 1 minus cosine squared down here. In my numerator, I just distributed sine times 1, sine times cosine. I factored out the sine on the top. And on the bottom, I wrote 1 minus cosine squared is sine squared, because that's what it is. I canceled there, sine and sine squared. It left 1 sine in my denominator. Now, anytime you have 2 things in your numerator and 1 on the bottom, you can break that up into 2 fractions. And I'm doing this because I keep looking back to what I need it to be. I need a cosecant and a cotangent. And I'm sitting there looking at that. That right there is my cosecant. And if I look at that, that's my cotangent. So I just split it up. Then I wrote cosecant plus cotangent, and that's it. Let's go to 10. Obviously taking the left-hand side here, and I just changed everything to sines and cosines. All right, so that's a bunch of stuff right there. And what started happening when I did that is all of a sudden these cosines canceled. So it's 1 over sine cubed. Over here, that cosine and that cosine cancels, so the cosine squared. The good thing is I have sine cubed on the denominator for both of them. So I wrote 1 minus cosine squared, which is really sine squared over sine cubed. Cancel those, just leaves a sine in the denominator, and 1 over sine x is cosecant x. 11, more of the same. I think I took, yes I did, I took the left-hand side and changed everything to sines and cosines, first step. Then, because I found anytime I have fractions in a fraction, I usually try to get rid of them. So what I did is I multiplied by the common denominator, which is cosine squared. So my numerator, my cosine squareds cancel, so I just brought over to sine squared. In my denominator, I did 1 times cosine squared right there, and then cosine squared times here, which is cosine x. I'll keep looking up here what I'm looking for. I need all cosines, so I changed my numerator to 1 minus cosine squared. And I take the bottom down here and I factored it, kind of like what we did in class today, which when you're watching this will be yesterday. Factor the top of this one, because I'm noticing that's the difference of squares, and that right there is going to be very common to what you get up here when you factor. So I factored to 1 plus cosine and 1 minus cosine, and once I did that, those cancel, which leaves me 1 minus cosine on the top and cosine on the bottom, which is exactly what I was trying to get. Oh, we didn't. Man, these just keep on going. We just did 12, didn't we? Let me go back and look. Okay, 12, 12, 12, 12, more of the same. I did this one the same way I did the last one. I changed everything. I took the left-hand side and changed everything to sines and cosines. Let's see what I did next. I multiplied next by the LCD. I didn't really show what the LCD was. The LCD is this right here. It's sine squared cosine squared. I forgot my x. Okay, so I multiplied the whole top by that. When I multiply 1 times that, I get this. If I do this times this, the cosines cancel, so I get sine to the 4th. Same thing on the bottom. 1 times this is that. Multiply this term times this. The sine squares cancel, gives you cosine to the 4th. So what I did next is I factored the top. I took out a sine squared. On the bottom, I factored the bottom, took out a cosine squared, which left me this stuff inside. Now those two things aren't the same. And I think we talked about this year. If not, you should have done this in Algebra 1. you're allowed to cancel opposite terms, but as long as you cancel, you get a -1. Don't forget you get a -1 right there when you cancel opposites. Or you can factor out a negative first and then change it around and still have a negative, as long as you have a negative somewhere. Since those cancel, it leaves me a negative sine squared over cosine squared. Now, that's pretty good. I'm thinking about being negative tangent squared, but look back what we want. We want that. So the denominator is perfect. The top, I went ahead and wrote 1 minus cosine squared, but don't forget the negative sign. And what the negative sign does is it changes the sign of what's inside there, which makes it cosine squared x minus 1 over cosine squared, which is perfect. 13, now we're just solving equations. So what I did, this is pretty quick. I moved that tangent over there. I moved the square root of 3 over, so it gave me tangent x is square root of 3. Tangent is square root of 3 at pi over 3. Remember we talked about those, since that's just 1, 3, it's 1, 3 down here. So pi over 3 plus n pi. The reason I did n pi is because the period of tangent is pi. Tangent's also positive in quadrant 3, which is 4 pi over 3, plus n pi. Again, n pi because the period is just 1 pi. 14, I moved the 1 over first, got 3, divided both sides by 4, so I got 3/4, but it's sine squared, so you got to take the square root of both sides, so I took the square root of each side. And when you take the square root of a fraction, remember you take the square root of the top, which is square root of 3, square root of the bottom, which would be 2, and so it's plus or minus square root of 3 over 2. Now, because it's plus or minus, that means every quadrant can have an answer. And because it's square root of 3 over 2 and the sign, it's all the pi over 3. So I put all the pi over 3's and added 2 n pi because the period of sine is 2 pi. All right, 15, 16. 15, now this time we're using the interval, so that means we don't have to have all those answers with the 2 n pi and the n pi. So 15, what it is, I move the cosine x over. And I got that. Remember, it's hard to solve when you have like a sine and a cosine unless you can factor one out, and this time we could. I factored out the cosine. That left sine x minus 3. So either cosine is 0 or sine is 3. And hopefully remember, sine cannot be 3 because sine cannot be bigger than 1. So you got to figure out where is cosine 0. And cosine is 0 on the y-axis, which is pi over 2 and 3 pi over 2. Let's go to 16 here. 16, kind of what I was saying a second ago, you cannot, it's hard to solve them with cosine and sine in them both in the same equation. So what it is, I'm going to take out the cosine squared. I'm doing the cosine because it's squared. Sine's not squared, so it's hard to change that one. You'd have to square stuff, and that's a lot of work. So I changed the cosine squared to 1 minus sine squared. Don't forget the 2's out here. And so then I distributed the 2. Let's see, I added the 2 over here with the minus 1 over there and got a, oops, got another one. Glad I'm doing this. When you add 2 and minus 1, oh, I see what I did. Never mind. I'm good. So what I did is I added those and I got a plus 1. But because my sine squared is negative, what I did at the same time is I changed all my signs. So that's what I did. I did the 2 minus 1, but then changed all the signs, so my first term would be positive. And then I just factored, and some of y'all were having some trouble with that today, but you got to get there. Factored it. This gave me sine x as a half. This one gave me sine as -1. Sine is a half at pi over 6, and also quadrant 2, 5 pi over 6. Sine is -1 at the bottom of the y-axis, which is 3 pi over 2. 17. 17, you have a secant and a tangent. You can't work it unless they're the same, and you can't change them unless one of them is squared or whatever. So what I did first, I squared both sides. When you square both sides, don't forget the shortcut to do that. Square the first one, multiply together, double, square the second one, and then I squared tangent over here. Because I have a secant here that's not squared, I'm not going to change the secant squared to tangent. I'm going to change the tangent squared to secant, which I did right here, using the fact that tangent squared plus 1 is secant squared. And once I wrote that, the secant squares cancel. So I brought the 2 secant x down. I took that 1 over there, gave me -2, divided by 1. So secant is -1. I did reciprocal of both sides. The cool thing about that is the reciprocal of -1 is still -1. So I got to figure out where cosine is -1. It's on the left side of the x-axis, which is pi. Okay, we're skipping 18, 19, and 20. You're welcome. I thought we might get there this week, but I knew after Monday we weren't getting there. Just didn't eliminate off the test. Also skipping 21 and 22. Those are this week. And here we go, the review stuff. 23. Sorry. Got to find the same base. So I'm taking the 8 and the 32 and writing them both as 2's. 8 is 2 cubed, x plus 4. 32 is 2 to the 5th, 3x. Multiply your exponents. So I did 3x plus 12. Here's 15x. You can now drop the bases because they're already equal. Set the exponents equal, and I did two things at once. I went ahead and moved the 3x over there. Gave me 12x equals 12. Divided by 12 and got 1. 24. Great thing about 24 is it's already factored for you. You can go ahead and take those 2 points, put them on a number line. 5/4 came from there. That's a 0. 4 came from there. What I did is I plugged in 0 to see what sign. Remember, the signs are going to alternate on your number line. So I plugged in 0, and when I did that, it gave me -5 and -4. -5 times -4 is positive 20, so it was 20, which means that's plus, that's minus. I also plugged in a big number just to double check, and it worked also. It was positive. So I'm looking for where the answers are positive. Where is it greater than or equal to 0? It's greater than 0 from -infinity to 5/4, so it's a bracket because it's equals, and also from 4 to infinity because, again, there's a bracket because it's equals. 25, pretty big problem here. First thing you can do is square both sides, so I squared this side. This side, don't forget, square, multiply together, double, that's where the 6 came from, and then square, the square root just goes away. I did a couple things at once here. 9 plus 2 is 11. I moved 11 to the other side, added it with the 7, got -4. Also moved the x over. It was a -x, moved it over. It was positive x, added that one's 2x. Then to get rid of the other square root, I squared both sides again. I squared here, squared there, squared everywhere. And when I squared there, again, square, multiply, double square. Here, square the 6 and square root. I distributed the 36. Then I moved stuff over. I took the 36 over. That gave me a positive 20. I took the 72 over. That gave me -56. Then what I noticed is all those numbers right there are divisible by 4. So I took a 4 out of all those just to make it easier to try to factor, which it did a whole lot. I had to figure out factors of 14 that would give me 5, and it was 7 and -2. So my two answers were -7 and 2. But don't forget, when you have a radical equation, you must check your answers. When I plugged in -7, it made that side 0 and did not make that side 0, so that didn't work. When I plugged in 2, it worked perfectly, so their answer is 2. Last one, finally, 26. The difference quotient is back even after fall break. So what you do is you take this right here, and you plug in a plus h right there, which I did. Then you take the a, plug it in right there, which I did, all over h. Then you got to simplify. So what you do is you multiply, remember, fraction to fraction, multiply top and bottom by the LCD. There's what that is. So what happens is when you multiply the numerator times all that stuff, on this one, this fraction, the h plus 4 would cancel, so that just leaves a plus h. On the second one, the a plus 4s would cancel, so it would just leave that part, which I wrote right there. There's a minus sign in between. I showed you the next step. I took the minus sign and distributed it just like that. And then what happens is the a's cancel, the 4s cancel. All that leaves is a -h on the top. But there's a bunch of stuff on the bottom. All that stuff's in your denominator. So then what happens, you can cancel your h's. But because one of them is negative, you need to leave the -1 in your numerator. And you got it. Wow, that's quite a video. Hope it helps. Watch as much as you need to. I'll allow skipping on it so you can skip around and watch whatever you need to as much as you need to. Hopefully we'll do great. And I will see you back on Friday.